Today I will present a classification analysis based on the cirrhosis disease stage classification dataset. Cirrhosis is a late stage of liver disease caused by long-term damage such as alcohol or any other type of chronic liver disease. So earlier identification of patients at high risk of advanced cirrhosis is critical as it allows for earlier intervention and improved clinical outcomes. So the dataset comes from a clinical trial conducted between 1974 and 1984 and includes some clinical and laboratory measurements from patients diagnosed with primary biliary cirrhosis. Our business problem is to build a classifier that predicts whether a patient has advanced cirrhosis or not using available clinical features. So, for the whole data, firstly, it imports some libraries, and it got a data dictionary, got some explanations for each columns. And then it got a reading the data set, so we can see each column names is each single features. And it first removed the redundant ID columns, and then they grouped the features by type. So quantitative features include age, or end days or some label columns. And also while categorical features include drug type, sex, and clinical science. And the target variables is the disease stage. So the model also extracted the unique value in the status column. We can see that patients have three possible status, like C for cancer, CL for cancer due to liver transplantation, and D for death. And second, exam some missing values. It count for some missing values. So you can see they got 106 in drug and got some even more in other features. And so because missingness was sustained shown in some numerical features, so it filled the missing value with just simple 0 as a simple and transparent baseline strategy. And the original target variable stage, they have 4 levels representing the historical disease stages from 1 to 4. So we are encoded as a binary classification where stage 4 is labeled as 1, indicating advanced cirrhosis, and stage 1 through 3 are labeled as 0. And third, it also examined the skewness in numerical variables and applied a long transformation to highly skewed features. This helps stabilize the variance and reduce the influence of extreme values. Finally, to further control the impact of outliers, it identified outliers using a modified Tukey rule and then applying Winsorization to cap extreme values at the 5th and 95th percentiles. Besides, it updates the main data frame with these transformed features and replaces any remaining non-values with zeros to ensure the dataset is stable and complete for modeling. So after processing all these quantitative features, let's examine the categorical features. So this step is going to convert categorical text variables into binary numerical columns so the model can process them while also restructuring the dataset by concatenating features with the target variable y and checking for class balance. So the result is about 0.34, which means that about 34% of patients are classified as having advanced cirrhosis. To analyze the relationship between clinical variables, this code also calculates correlations and visualizes it as a heat map. So allowing for the identification of strong linear associations between features and their potential influence on the target diagnosis. The correlation heat map reveals like some significant multicollinearity among like several clinical features. Particularly, we can see between like Cooper alkophosph with like coefficients as high as like 0.97, like suggesting that like maybe some variables may be like redundant for the model. So it all let's move to like classifications. So it uses like a validation strategy, splitting the data set into like 18% training data and 20% test data. This allows us to evaluate how well the model generalizes to unseen patients. So numerical features are standardized and applying SMOD to balance the cirrhosis classes. So firstly, we do the like decision trees. So for the decision trees, it utilizes an imbalanced learned pipeline to train a decision tree classifier, evaluating its performance on the holdout sample through accuracy scores and confusion metrics. So decision trees are like well suited for clinical data because they can capture non-linear relationships and also interactions among variables, and their structure is relatively interpretable. So a decision tree achieved an accuracy of about like 63.1%, indicating a moderate like predictive power. But it also like reveals that the model struggling to distinguish between the two classes effectively, like while it correctly identifies 38 healthy or early stage cases, it also failed to detect like 16 cirrhosis cases and misidentified 15 cases as positive. So next we do the like local classifier. It's a like H2O auto machine learning tool, like automatically like trains and tunes like multiple algorithms within a set time limit to find the best model with the best performance. So by handling class balancing and cross validation automatically, it provides a highly optimized diagnostic model for liver cirrhosis stages, so outperforming manual like model selections. So this model like just trains multiple models, including maybe linear models, tree-based models, and so on. So this one, so this model like it chooses the leader model is the GBM. We can see from like the result here. Wait 1 minute, 1 second. It's called like GBM. So this full name should be gradient boosting machine. So like it consisting of like 31 trees, which achieved a really strong training AUC of 0.89 and a cross accuracy of 77%. So the variable importance section reveals that albumin and like indase here. These two are the like most important predictors for identifying the cirrhosis stages in this module. So the progressing from like manual decision tree modeling, which got a 63.1% accuracy, to H2O auto machine learning got a 84% accuracy, demonstrates that ensemble methods like GBM are far more effective at capturing complex clinical patterns in liver cirrhosis data. So while the identification of albumin and bilirubin as top predictors provides valuable diagnostic focus for real-world screening, the remaining false negatives in the confusion matrix emphasize that these like tools should be used as a supportive second opinion rather than a like only one diagnostic tool. So that's all. Thank you.